Good morning, vibrant city of Valenzuela. Welcome to Valenzuela Live, your live streaming school. This is Oliver G. Mariano from Citero Francisco Memorial National High School. Join me as we unfold a one-of-a-kind learning experience in Mathematics 10. Are you ready? Let's start. We are now on the first lesson of the first quarter, which is about number patterns and arithmetic sequence. At the end of this session, you are expected to meet the following most essential learning competencies. First, generate patterns. Second, illustrate an arithmetic sequence. And third, determine the nth term of an arithmetic sequence. Let's have our first activity entitled, Please Be the Next. I will be flashing a list of words, numbers, or figures, and what you have to do is to find out what comes next in the list. You will be given 20 seconds to key in your answer in the comment section. Are you ready? Okay, let us begin. What is next in the list below? Triangle, pentagon, heptagon, nonagon, and blank. Your 20 seconds starts now. All right, time is up. If your answer is undecagon, then you're right. Now, what have you noticed about the words in the list? Great. They all refer to polygons with an odd number of sides. Let's go to the second one. What is next in the list below? 2, 4, 8, 16, and blank. You've got 20 seconds. Go. Ten seconds left. Hurry up, grade 10. That's it. Time is up. The correct answer is 32. What do you observe with the numbers in the list? Great. These numbers are the powers of 2. What about here? Can you determine what comes next in C, CC, CCC, and CD? 20 seconds. Go. All right, you're left with 10 seconds. Come on, type in your answers in the comment section. Okay, time is up. Let's see the correct answer. Yes, it's B. Did you get the same? Very good. What have you observed about these characters? Nice. These are the multiples of 100 written in Roman numerals. It seems that you're great in observing patterns. Nice start, grade 10. Moving on, you may have observed that the entries in the lists shown in our first activity occur in a certain order. Such are examples of what we call sequence. But what is a sequence? A sequence is a collection of objects that follows a certain pattern. In our surroundings, there are many objects or phenomena that also possess a pattern. You may see beautiful patterns in the eye spots found in the feathers of a peacock. You may also observe patterns on how spiders weave their webs. You may also get fascinated about the disc flowers located at the center of the head of a sunflower. Indeed, almost everything around us follow a certain order or pattern. Isn't that amazing? Nice. Now, let's observe another sequence as depicted by the figures below. I want you to carefully examine the given figures, and I'll give you 15 seconds to do that. And that starts now. Okay, time is up. How many dots are used in forming the first figure? Good. There's only one dot in the first figure. What about in the second figure? Great. There are 3 dots in the second figure. How about in the third figure? Nice. 6 dots were used to form the third figure. And for the fourth figure? Very good. 10 dots were used in forming the fourth figure. Now, let us look at the differences between each number and its preceding one in this sequence. What's the difference between 3 and 1? You're right. That is 2. What about between 6 and 3? Great. That is 3. And what about 10 and 6? Amazing. That is 4. Do you see the pattern in this sequence? Nice. It's good that you can see that the next terms of this sequence are obtained by adding the next counting number. Can you predict the next numbers of this sequence? Well, that's incredible. Let's now take a look at some important concepts about sequence. First, the terms of a sequence are the function values f of 1, f of 2, f of 3, and so on up to f of n, which are commonly written as a sub 1, a sub 2, a sub 3, and so on up to a sub n. The number a sub 1 is called the first term, and a sub 2 is called the second term. Generally, a sub n is called the general term or the nth term. As an illustration, let's take this sequence. Again, we have observed that a sequence is evident in these figures. Writing down the terms of the sequence, we have 1, 3, 6, 10, 15, 21, and so on. 1 is considered as the first term and is denoted by a sub 1. 3 is the second term of the sequence and it's denoted by a sub 2. Similarly, 6 is the third term and is denoted by a sub 3. While 10 is the fourth term and is denoted by a sub 4. Likewise, our fifth term is 15 and is denoted by a sub 5. Can you still follow? Great. Another concept that you need to be familiar with is about the difference between a finite sequence from an infinite sequence. A finite sequence is a function f whose domain is the set of natural numbers 1, 2, 3, and so on up to n. To illustrate, let's have this example. 1, 3, 6, 10, 15, and 21. This is a finite sequence, and its domain are the numbers from 1 to 6. Therefore, it has, yes, you're right. This sequence contains exactly 6 terms. Always remember that a sequence is considered finite if you can exactly count the number of terms that it has. When the domain of a sequence is the entire set of natural numbers, then the sequence is said to be infinite. As an illustration, we have 1, 3, 6, 10, 15, 21, and so on. In this sequence, the terms continue endlessly, and this is denoted by the 3 dots called ellipses. Are these concepts now clear to you? Very good. Lastly, we define what we call general term or nth term. The general term or the nth term of a sequence is an expression that generates the terms of a sequence. Interestingly, the general term becomes an explicit formula which may be used to determine any term of the sequence without knowing the previous terms. Are you now ready to apply the concepts that you have learned so far? Nice. Let's begin with this example. Example number 1. Give the general term of the sequence 7, 13, 19, 25, and so on, and determine the 20th term. First, let's write the given sequence and observe its pattern. Can you describe the pattern in this sequence? Good. We can clearly see that the difference between 13 and 7 is 6. Same for 19 and 13. As well as between 25 and 19. Clearly, we can write 7 as 6 plus 1. Rewriting it further, we can say that a sub 1 is equal to 6 times 1 plus 1. Likewise, 13 is equal to 6 plus 6 plus 1, which we can rewrite as 6 times 2 plus 1. Next, observe that 19 is equal to 6 plus 6 plus 6 plus 1. So our third term may be written as a sub 3 is equal to 6 times 3 plus 1. 25 is equal to 6 plus 6 plus 6 plus 6 plus 1, which means that a sub 4 is equal to 6 times 4 plus 1. What do you observe between the order of the term and the number inside the parentheses? You're right. They are the same. Note also that 6 and 1 are fixed. So, if we find the general term or the nth term, we can say that a sub n is equal to 6n plus 1. Did you get it? Great. Let's continue answering the problem by finding the 20th term. First, we rewrite the obtained general term, which is a sub n is equal to 6n plus 1. Then we plug in the value of n, which is 20. So we have a sub 20 is equal to 6 times 20 plus 1. But 6 times 20 is equal to, or 6 times 10 is 120. And this results to a sub 20 is equal to 120 plus 1. Therefore, 120 is equal to 121. Did you get it? Awesome. Let's now move to our next example. What are the first 5 terms and the 10th term of the sequence defined by a sub n is equal to n squared plus 1. To find the indicated term, we simply substitute the corresponding value for n. To begin with, let's find the first term. The general term is a sub n is equal to n squared plus 1. Substituting 1 in place of n gives us a sub 1 is equal to 1 squared plus 1. The square of 1 is also 1. So we have a sub 1 is equal to 1 plus 1. Therefore, a sub 1 is equal to 2. Next, let's find the second term. To begin, we write the general term, which is a sub n is equal to n squared plus 1. Since n is equal to 2, by substitution, we have a sub 1 is equal to 2 squared plus 1. The square of 2 is 4. So we obtain a sub 2 is equal to 4 plus 1. Hence, a sub 2 is equal to 5. Let's proceed to finding the third term. Again, the general term of the given sequence is a sub n is equal to n squared plus 1. If n is equal to 3, then we get a sub 3 is equal to 3 squared plus 1. But the square of 3 is 9. So, a sub 3 is equal to 9 plus 1. Which means that a sub 3 is equal to 10. Can you still follow? Great. Let's move on to finding the fourth term. Still, the general term is a sub n is equal to n squared plus 1. By substituting n is equal to 4, we have a sub 4 is equal to 4 squared plus 1. But the square of 4 is 16. So, a sub 4 is equal to 16 plus 1. This implies that a sub 4 is equal to 17. And for the fifth term, we have a sub n is equal to n squared plus 1 as the general term. And with n is equal to 5 yields a sub 5 is equal to 5 squared plus 1. Squaring 5 gives us a sub 5 is equal to 25 plus 1. Thus, a sub 5 is equal to 26. Therefore, the first 5 terms of the sequence are 2, 5, 10, 17, and 26. Now, let's try to find the 10th term in the given general term. A sub n is equal to n squared plus 1. We substitute 10 to n. That is, a sub 10 is equal to 10 squared plus 1. But the square of 10 is 100. So, a sub 10 is equal to 100 plus 1. This goes to show that a sub 10 is equal to 101. Do you have questions so far? Feel free to drop them in the comment section. Let's look back to the sequence given in example 1. Again, the difference between the successive terms here is constant, which is 6. This, in fact, is an example of what we call arithmetic sequence. An arithmetic sequence is a sequence in which the difference between any two consecutive terms is a constant. This constant is known as the common difference, which is denoted by D. Hence, the above sequence shows that the common difference is 6. Let us do another activity called Wow Fact. In this activity, you need to hit the Wow React button if the given sequence is arithmetic. But if it's not an arithmetic sequence, hit the like react button. Is that clear? Very good. So let's start. Is the given sequence arithmetic? 8, 13, 18, 23, 28, and so on. You got 5 seconds to hit the correct react button, and that begins now. Okay, time is up. The sequence is, you're right, it is arithmetic. What do you think is the common difference? Nice. The common difference is 5. But why is it 5? Good. Because we observe the difference between the consecutive terms of the sequence, and it is constant, which is 5. What about this sequence? Is it arithmetic or not? 7, 4, 1, -2, and so on. Your 5 seconds starts now. All right, time's up. The given sequence is great. It is an arithmetic sequence. And what is its common difference? Yes, you are correct. The common difference is -3. And why is it -3? Great! Because the difference between every pair of consecutive terms is fixed and is -3. Consider the next sequence. Is it arithmetic or not? 3, 6, 12, 24, and so on. 5 seconds. Go. Time's up. The given sequence is not arithmetic. As you can see, the differences are not the same. Let's move on to the next item. Is the given sequence arithmetic? 2, 7/3, 8/3, 3, and so on. Hit the wow react button if it's arithmetic, and the like react button if it's not. Timer starts now. Okay, time is up. The sequence is, you're right, it is arithmetic with a common difference of precisely D is equal to 1/3. To show that we can see that the difference between a term and its preceding one is constant, which is 1/3. For the last one, we have 1, 1, 2, 3, 5, and so on. Does this sequence deserve a wow or a like? 5 seconds. Go. Time is up. If you hit the like react button, then you're right. The sequence is not arithmetic. Obviously, the differences between successive terms are not equal. It seems that you can really distinguish how an arithmetic sequence is defined. Good job, grade 10. Now, let's try to derive the formula for the general term of an arithmetic sequence, using again the sequence given in our example number 1. Here, we note that the common difference is 6. In the sequence, our first term is 7, which is generally denoted by A sub 1. There is no doubt that 7 is equal to 7. And that a sub 1 is equal to a sub 1. Next is our second term, 13. This may be denoted by a sub 2. Observe that 13 is obtained by adding 6 to 7. Thus, in general, a sub 2 is obtained through a sub 1 plus d. Continuing, we have 19, our third term, which is denoted by a sub 3. As you may have observed, 19 is equal to 7 plus 6 plus 6. In other words, a sub 3 is equal to a sub 1 plus d plus d. Do you see some similar terms here? Nice. Thus, we can combine them. And that results to a sub 1 plus 2d. The next term in the sequence is 25. And this is our a sub 4. Again, you will notice that 25 is equal to 7 plus 6 plus 6 plus 6. Thus, a sub 4 is equal to a sub 1 plus d plus d plus d. If we combine similar terms here, what do we get? Great! We obtain a sub 1 plus 3d. What do you observe with the entries in the last column of our table? That's right. A sub 1 is fixed. What else? Correct. The coefficient of d is always 1 less than the order of the term. Hence, from here we can say that if we continue the pattern, a sub n is equal to a sub 1 plus quantity n minus 1 times d. And this serves as the formula for the general term of an arithmetic sequence. In the general term of the arithmetic sequence, which is a sub n is equal to a sub 1 plus quantity n minus 1 times d, we note that a sub 1 is the first term. N is the number of terms in the arithmetic sequence. And d is the common difference. Let's now see how the general term is applied in the following examples. To begin with, we have example number 3. What is the 25th term of the arithmetic sequence with a sub 1 equals 7 and d equals 6? Let's now identify the known values. What's the value of n? Good. N is equal to 25. What about the first term? You're right. A sub 1 is equal to 7. What about the common difference? Great. D is equal to 6. Now, let's start solving by writing the general term of an arithmetic sequence, which is a sub n is equal to a sub 1 plus quantity n minus 1 times d. Substituting the known values here yields a sub 25 is equal to 7 plus quantity 25 minus 1 times 6. Subtracting 1 from 25 gives us a sub 25 is equal to 7 plus 24 times 6. Performing the operations here, we have a sub 25 is equal to 151. Did you get it? Awesome. Let's continue with another example. Example number 4. Which term of the sequence 8, 5, 2, -1, and so on is negative 37. Let's identify the known values in the problem. What is the first term of the sequence? You're right, it is 8. If we examine the terms, we can say that the common difference is great. The common difference is negative 3. Now, what does negative 37 refer to? Correct. It is the nth term. And we wish to know its order in the given sequence. We begin by writing the general term. A sub n is equal to a sub 1 plus quantity n minus 1 times d. Substituting the known values here gives us negative 37 is equal to 8 plus quantity n minus 1 times negative 3. Applying distributive property of equality results to negative 37 is equal to 8 minus 3n plus 3. Adding 8 and 3 yields negative 37 is equal to 11 minus 3n. By applying addition property of equality, we have negative 37 minus 11 is equal to 11 minus 3n minus 11. Subtracting, we obtain negative 48 is equal to negative 3n. Dividing both sides of the equation by negative 3 shows that n is equal to 16. This tells us that negative 37 is the 16th term of the given sequence. Should you have questions, do not hesitate to plug them in the comment box. Let's now proceed to another activity called Who Am I? I will be flashing a problem on arithmetic sequence and you have to solve it in 30 seconds. Once you're done, you may drop your answer in the comment box. Is that clear? All right. Here is the first problem. I am the 12th term of the arithmetic sequence whose first 3 terms are 6, 15, and 24. Who am I? 30 seconds. Go. Time is up. The correct answer is 105. Did you get the same answer, grade 10? Nice. Let us go to the second problem. I am the common difference of the arithmetic sequence with a sub 6 is equal to 29 and a sub 15 is equal to 65. Who am I? You have 30 seconds and that begins now. That's it. The correct answer is 4. Were you able to solve this problem correctly? Very good. Should you still have further questions, Feel free to raise your questions during your follow-up discussion tomorrow. Let's now summarize what you have learned from today's session. How do we find the general term of a sequence? To get the general term of a sequence, one may use pattern searching and other inductive strategies. How do we determine a specific term of a sequence? To find the nth term of a sequence, substitute the value of n to the given general term, then evaluate. How do we know if a sequence is arithmetic? A sequence is called arithmetic if the difference between any two consecutive terms is a constant. What's the formula for the general term of an arithmetic sequence? The general term of an arithmetic sequence is given by a sub n is equal to a sub 1 plus quantity n minus 1 times d. At this point, I would like you to reflect on what you have learned today through our activity entitled My One-Liner Takeaway. In this activity, I'd like you to fill in the blanks in the sentence, my biggest learning in mathematics today is blank. You may write it on a piece of paper or share this as your Facebook status or post it as your today's story. Congratulations, grade 10. Thank you for spending time learning number and patterns and arithmetic sequence with me. Now, the floor is open to address some of the frequently asked questions for this lesson, such as, does every sequence have a general term? The answer is no. Not all sequences have a general term. For instance, the sequence whose terms are the prime numbers. There is no known explicit formula that would generate these terms. Another, can a sequence be represented by two different general terms? This may happen if the sequence is finite. But for infinite sequence, the general term must be unique. And what happens to an arithmetic sequence if its common difference is 0? Well, if this happens, all the terms of the arithmetic sequence will be the same. Before we end this session, may I remind you all to answer the exercises given in the What's More portion of your module. Once again, this has been your mathematics teacher for today, bidding you a goodbye for now. Stay safe and healthy. Until next time.